For this video, we're going to be on page 163 of your workbooks, and it's under the section 7.5, but we're skipping over straight to activity 3. So we spent a couple of lessons ago talking about the Pythagorean Theorem. Okay, we said that the only shape you can use this with is a right triangle. And then the theorem states that a squared plus b squared has to equal c squared. Okay, and if you had a right triangle like this, here's your right angle, really the only side that mattered was c, your hypotenuse, and that was the side that was always directly across from the right angle, so that would be c. A and b will be the two legs, and it doesn't matter which one's A and which one's B. So what we're going to be doing and looking at in this video is finding the distance between 2 points on a graph, but being able to use the Pythagorean theorem to find the distance between those 2 points. So if you look at activity 3, step 1 just says follow the steps. So step 1 says choose 2 points in the coordinate plane that do not lie on the same horizontal or vertical line. So basically, we're going to be putting 2 points on this coordinate plane. They just can't be straight across from each other or straight up and down from each other. So let's say we have one here and we have one here. And then it says label them with their coordinates. So we'll label this one x1, y1, and we'll label this one x2, y2, just like they told us to. Step 2 says draw a line segment connecting the points. So I did that. And this will be the hypotenuse of a right triangle. Okay, so we'll keep that in mind as we keep going. Step 3 says to draw horizontal and vertical line segments from the points to form the legs of the right triangle. Now, there are 2 ways you could do this. Okay, I could complete my right triangle right here, or I could complete it right here, drawing a horizontal and a vertical line. I'm going to do the one down here. So we'll draw a vertical and a horizontal line. And do you see how it created a right triangle? Now, step 4 says use the x coordinates to write an expression for the length of the horizontal leg. So horizontal, okay, basically all we're doing is counting how long this segment is. So 1, 2, 3. This would be 3 units. And step 5, do the same thing for the vertical. This would be 1, 2. Okay, so finding that 2 and 3 was just simply counting how long each segment was. Now, step 6 says to substitute those into your equation for the Pythagorean theorem. So that would be 2 squared plus 3 squared equals, and then we're trying to find c right there, c squared. And really you could make that any variable you want. I usually just always use c because that's what it is in the formula. Okay, so step 7 says solve that equation for c. So again, we had 2 squared plus 3 squared equals c squared. So 2 squared is 4, 3 squared is 9, that equals c squared. 4 plus 9 is 13, equals c squared. And then remember to take, we don't want to know what c squared is, I just want to know c. So we have to take the square root of 13, and that will equal C. Now, if I pull up my calculator, because I know the square root of 13 is not a perfect square, so let's estimate that real quick. We get about 3.6. So we could say C is about 3.6 when I estimated that. So the question right here says, what does the length of the hypotenuse tell you about the 2 points? So what we just found was the distance between the 2 points is 3.6. Okay, and we did that by creating the right triangle and then using our formula for the Pythagorean theorem to figure that out. Now, one more thing we're going to look at. If you turn the page over to page 164, where it says 7.5 practice, I want to go over this first section, numbers 1 through 4. Okay, it says, tell whether the triangle with the given side lengths is a right triangle. So on these, they give us all 3 sides of the triangle, and they're asking us basically, is this a right triangle or not? Okay, so a couple things to keep in mind when you have a problem like this. And you can make this little note kind of up at the top. But the thing to keep in mind is that the hypotenuse, remember that's your C, is always the longest side. So whenever I am trying to figure these out, I'm going to use the biggest number, and that's going to be put where the C is. So let's look at number 1. I have 14, 10, and 18. So if I am truly going to figure out if this is a right angle or not, the way I would set up my equation, the only thing that matters is, since 18 is the largest number, it has to be put in place of the C in the equation. So we would have 14 squared plus 10 squared equals 18 squared. And as I go to solve this, what I'm looking for is, if I end up getting 2 numbers that are equal, then yes, it's a right triangle. If I end up getting 2 numbers that are not equal, then it's not a right triangle. So let's start to solve this. Okay, 14 squared is 196, 10 squared is 100, and 18 squared is 324. And when I add these two together, 196 plus 100 is 296 equals 324. That is not true. So because those are not true, no, this is not a right triangle. Okay, let's look at number 2. Again, the longest side has to be in place of the C, so that would be the 26. So I'm going to have 10 squared plus 24 squared equals 26 squared. And then I'll start to solve this. Again, 10 squared is 100. I'm going to pull out my calculator to figure out these other ones. Okay, if I have 24 squared, that is 576. And 26 squared is 676. If I add these together, 100 plus 576 is 676. Okay, and this checks out. Those two are equal. So for the answer to this one, we would say yes. that is a right triangle. Now, we can also do it without even having a picture, just a list of the numbers, like on 3 and 4. So just keep in mind the biggest number you have is going to be in place of the C. So on number 3, biggest number I have is 5.8. So as I set this up, I have 4 squared plus 4.2 squared equals 5.8 squared. 4 squared is 16. Pull up my calculator for this one. Okay, 4.2 squared is 17.64. And 5.8 squared is 33.64. Okay, when I add these two together, you end up getting 33.64 equals 33.64, and that checks out. So yes, these three sides would make a right triangle. Okay, so what I want you to do is do the same thing on number 4 and figure out if these three sides could be the sides of a right triangle. So go ahead and pause the video, and then the question will pop up over to the right, and you'll go ahead and input your answer, just yes or no, and then you'll find out if you are right or not. Now, we are going to talk more about finding the distance between these 2 points. Okay, you could graph them like we did on the previous page and create a right triangle. Okay, but in the next lesson, we're actually going to have a formula where you don't have to graph them. You just plug numbers into a formula to figure out the distance between the two of them.